Welcome to Azure Extended Network. Today we're going to explore one of Azure's most powerful networking features, Azure Extended Network. This technology allows you to literally extend your on-premises network subnet into Azure, creating a seamless bridge between your data center and the cloud. Think of it as taking a physical network cable from your data center and plugging it directly into Azure. Your VMs in Azure can have the exact same IP addresses as if they were sitting in your on-premises rack. This is particularly valuable for lift and shift migrations where changing IP addresses would break applications or require extensive reconfiguration. Understanding the architecture. Let me walk you through the high-level architecture. At its core, Azure Extended Network creates a Layer 2 bridge between your on-premises network and Azure. On the left, you have your on-premises infrastructure, physical servers, Hyper-V hosts, and network switches. On the right, you have Azure with hub and spoke virtual networks. The magic happens through the Extended Network Gateway, which acts as a bridge. It takes Layer 2 Ethernet frames from your on-premises network, encapsulates them, sends them through a VPN or ExpressRoute tunnel, and then decapsulates them in Azure. This means your Azure VMs appear as if they're on the same physical network segment as your on-premises resources. Detailed network topology. Now let's dive deeper into the network topology. In your on-premises environment, you typically have physical servers in the 192.168.1.10 to 50 range, and Hyper-V hosts in the 51 to 100 range, all connected through a top-of-rack switch with VLAN 100. Your network edge includes firewalls, core routers, and VPN devices that establish the site-to-site connection to Azure. In Azure, you have a hub virtual network with a dedicated address space like 10.0.0.0/16. This contains the VPN gateway in the gateway subnet and the extended network gateway in its own subnet. The spoke virtual network uses the same address space as your on-premises network 192.168.0.0/16, and this is where your extended subnet lives. Azure VMs get IP addresses like 192.168.1.101, 102, 103, continuing the same numbering scheme from on-premises. How traffic flows. Let me explain exactly how network traffic flows in this setup. It's quite elegant when you understand the sequence. When an on-premises VM wants to communicate with an Azure VM, it first sends an ARP request asking, who has IP 192.168.1.101. This ARP request travels through your network switch, goes through the VPN gateway, and gets transmitted via the encrypted tunnel to Azure. The Extended Network Gateway receives this ARP request and broadcasts it to the Azure VMs. The target VM responds with its MAC address, and this response travels back through the same path. Once the ARP is resolved, actual data packets flow seamlessly. The on-premises VM sends data to the switch, which routes it to the VPN gateway, through the encrypted tunnel, to the Extended Network Gateway, and finally to the Azure VM via Layer 2 bridging. From the application's perspective, it's as if both VMs are on the same physical switch. Layer 2 bridging explained. This diagram illustrates the key concept behind Extended Network. Layer 2 bridging across a Layer 3 transport. Your on-premises environment operates as a Layer 2 domain with VLAN 100 and the 192.168.1.0/24 subnet. Azure also needs to operate as the same Layer 2 domain with identical addressing. The challenge is that between these two environments, you have a Layer 3 connection, either IPsec VPN or ExpressRoute. Layer 3 doesn't normally carry Layer 2 frames. The Extended Network Gateway solves this by encapsulating Layer 2 Ethernet frames into Layer 3 packets for transport, then decapsulating them on the other side. This creates the illusion of a single, extended Layer 2 broadcast domain spanning both environments. Before we start implementing, let's review the critical prerequisites and non-negotiable requirements for the Extended Network feature to work. First and most important, you must have a Hyper-V environment. Extended Network is specifically designed for Hyper-V and will not work with VMware or other hypervisors. You need Windows Server 2019 or later on your Hyper-V hosts. You also need either a site-to-site VPN or an ExpressRoute connection already established. From a network design perspective, you need a dedicated VLAN for the subnet you want to extend. Your routing must be configured to send traffic destined for Azure through the VPN or ExpressRoute connection. Finally, the following Azure resources are also required: a VPN or ExpressRoute gateway, the Extended Network Gateway, a Hub Virtual Network, and a Spoke Virtual Network. Proper address space planning for these is essential. Implementation dependencies. This diagram shows the exact order you must follow when implementing Azure Extended Network. Each step depends on the previous ones, and skipping or reordering steps will cause failures. We start with the resource group, then create the Hub Virtual Network. The gateway subnet must be created before the VPN gateway, and you need a public IP for the VPN gateway. Once the VPN gateway is deployed, which takes 30 to 45 minutes, you can configure your on-premises connection. The extended network subnet and gateway can be created in parallel with the VPN setup. After both gateways are running, you create the Spoke Virtual Network with the extended subnet, configure v.net peering, and finally deploy VMs. The final step is configuring the Hyper-V integration on your on-premises hosts. This order ensures all dependencies are met and reduces troubleshooting time. Creating the foundation. Let's start with the foundational Azure resources. First, we create a resource group to contain all our extended network components. I always recommend using descriptive names and proper tagging. The resource group name should clearly indicate its purpose, and tags help with cost tracking and governance. Next, we create the Hub Virtual Network. This will house our gateways, so we use a non-overlapping address space like 10.0.0.0/16. This gives us plenty of room for gateway subnets and future expansion. The location should be the Azure region closest to your on-premises location to minimize latency. Tagging the VNet as tier equals hub helps identify its role in your network architecture. Setting up gateway infrastructure. Now, we create the specialized subnets needed for our gateways. The gateway subnet is a reserved name in Azure. It must be exactly gateway subnet, using that exact capitalization. This subnet is exclusively for VPN and ExpressRoute gateways. I recommend using at least A27 for production environments to provide enough IP addresses for high availability configurations. The extended network also needs its own dedicated subnet. Unlike the gateway subnet, you can name this whatever you want, but extended network subnet is descriptive and clear. These subnets cannot share IP space with other resources, so plan your addressing carefully. In this example, we're using 10.0.1.0/24 for the gateway and 10.0.2.0/24 for the extended network. VPN gateway configuration. Creating the VPN gateway involves several steps. First, we need a static public IP address. This IP will be used by your on-premises VPN device to establish the connection, so it must be static. I always use the standard SKU for public IPs in production environments. It provides better features and reliability compared to the basic SKU. The VPN gateway creation is where you'll wait the longest, typically 30 to 45 minutes. I use the VPN GW2 SKU, which provides up to 1 gigabit per second throughput and supports 30 simultaneous tunnels. The no wait flag is crucial here, because otherwise your terminal would be locked for 45 minutes. You can check the deployment status in the Azure portal or with AZ commands while it's building. On-premises connection setup. Now we define the on-premises side of the connection. The local network gateway represents your on-premises network to Azure. The gateway IP address must be the public IP of your on-premises VPN device. The local address prefixes are all the on-premises subnets that need to communicate with Azure. Make sure to include every on-premises subnet that will participate in the extended network or communicate with Azure resources. You can add multiple prefixes as shown in the example. The VPN connection ties everything together with a pre-shared key. This key must match exactly on both sides, Azure and your on-premises VPN device. Use a strong, randomly generated key and store it securely. Extended network components. Now we create the Spoke virtual network that will house our extended subnet. This is where the magic happens, as this v.net uses the same address space as your on-premises network. In this example, we're using 192.168.0.0/16 to match our on-premises addressing. The extended subnet must be exactly 192.168.1.0/24 to match the on-premises subnet we're extending. The extended network gateway is different from a VPN gateway. It's specifically designed for Layer 2 bridging and must be deployed in its own dedicated subnet in the hub v.net. This gateway typically takes 15 to 30 minutes to deploy, which is faster than the VPN gateway but still requires patience. The standard SKU is usually the only option available for extended network gateways. VNET peering configuration. VNET peering is what connects our hub and spoke networks. This isn't just basic peering. We need specific configurations for extended network to work properly. The hub-to-spoke peering must allow gateway transit because the hub hosts the gateways that the spoke will use. We also enable forwarded traffic to allow the extended network traffic to flow. The spoke-to-hub peering is configured to use remote gateways, meaning it will use the gateways in the hub VNET rather than having its own. Both peerings must be configured for the connection to work. Azure requires bidirectional peering, and the settings must be complementary. If one side allows gateway transit, the other side must use remote gateways. Creating the extended network link. This is the step that actually creates the Layer 2 bridge. The extended network resource links the extended network gateway to the target subnet in the Spoke v.net. You need the full Azure Resource Manager ID of the target subnet. This is a long string that includes your subscription ID, resource group name, v.net name, and subnet name. Make sure to replace the placeholder, your subscription ID, with your actual subscription ID. You can get this from the Azure portal or by running the command as_account_show query id. Once this resource is created, the extended network gateway will start bridging Layer 2 traffic between on-premises and the specified Azure subnet. This usually takes just a few minutes to become active. Now, let's deploy a test VM to verify our extended network is working. I'm using Windows Server 2019 because it integrates well with Hyper-V environments and provides good troubleshooting tools. The critical parameter here is the private IP address. I'm using 192.168.1.101, which is in the same subnet as our on-premises VMs but doesn't conflict with existing addresses. Choose an IP that makes sense in your numbering scheme. If your on-premises VMs use 192.168.1.10 through 100, then starting Azure VMs at 101 creates a logical separation while maintaining the same subnet. The VM size standard _D2s_v3 provides good performance for testing. Once deployed, this VM should be able to communicate directly with on-premises VMs using their existing IP addresses. Next, let's discuss the Hyper-V integration setup. The final piece is configuring your on-premises Hyper-V environment. This is where the extended network feature is installed and configured. First, you install the extended network Windows feature on your Hyper-V hosts. This adds the necessary drivers and services to support Layer 2 bridging to Azure. The new extended network connection command creates the connection to Azure. You'll need the Azure connection string, which includes storage account details for synchronization. If you're using VLANs, which I recommend for network isolation, you need to configure the VLAN ID that corresponds to your extended subnet. In this example, we're using VLAN 100. The VM switch name must match an existing external Hyper-V switch that's connected to the network segment you want to extend. Troubleshooting common issues. When extended network isn't working, I follow this systematic troubleshooting approach. Start with the basics. Is the VPN connection actually established? Many issues stem from VPN connectivity problems. If the VPN is down, nothing else will work. Check both the Azure side and your on-premises VPN device status. If the VPN is connected but extended network isn't working, check the gateway status. Both the VPN gateway and the extended network gateway must be running and provisioned successfully. Next, verify the ARP table on your VMs. If Layer 2 bridging is working, you should see MAC addresses for both on-premises and Azure VMs in the same ARP table. Finally, check your Hyper-V configuration. The extended network feature must be properly installed and configured with the correct VM switch and VLAN settings. Monitoring and diagnostics. Here are the key diagnostic commands I use to troubleshoot extended network issues. These commands help you verify each component is working correctly. The first command checks your VPN connection status. You should see connected if everything is working properly. The second command verifies that your extended network gateway is properly provisioned. Look for succeeded in the provisioning state. The third command shows details about your extended network connection, including which subnet it's bridging and the current status. I recommend running these commands regularly and setting up monitoring alerts to notify you if connections go down. Extended network issues are often connectivity related and can be resolved quickly if detected early. Production best practices. Let me share some critical best practices I've learned from implementing extended network in production environments. Network segmentation is crucial. Use dedicated VLANs for extended networks to isolate traffic and improve security. This also makes troubleshooting much easier when issues arise. Implement comprehensive monitoring on both Azure and on-premises environments. Extended network spans 2 environments, so you need visibility into both. Apply network security groups to your Azure VMs even though they're on the extended network. Defense in depth is always important. Maintain detailed network diagrams and IP allocation records. Extended networks can become complex quickly, and documentation is essential for operations teams. Test failover scenarios regularly. What happens if the VPN goes down? How long does it take to restore connectivity? Plan for these situations before they become emergencies. Command reference summary. This final diagram summarizes the command dependencies and execution order we've covered. Green represents the starting point, yellow shows critical connectivity components, and red indicates the final VM deployment. Remember that gateway deployments take significant time. Budget 30 to 45 minutes for VPN gateways and 15 to 30 minutes for extended network gateways. Plan your implementation accordingly. The table shows estimated deployment times for each step. Use this to plan your implementation windows and set proper expectations with stakeholders. Extended network is a powerful technology that can significantly simplify cloud migrations, but it requires careful planning and proper implementation. Follow this sequence, and you'll have a robust extended network that seamlessly bridges your on-premises and Azure environments. Thank you for following along with this Azure Extended Network Implementation Guide.